Hello viewers, welcome to my channel KK Concepts of Electrical Engineering. Finding capacitance of parallel plate capacitor using Laplace equation. Application of Laplace equation. Let us consider a parallel plate on x-axis. This is at 0, so x equals to 0 and this is x equals to x1, and the voltage V is equals to 0 here and V equals to V1 here. This is negative plate and this is a positive plate. Now the distance between these two plates is T. Let surface area S and separated by a distance D. These are boundary conditions. Laplace equation del square V equals to 0 at rho V equals to 0. Dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square equals to 0. Now from the figure, these two are on yz plane and the variation is on x plane, and this is electric field intensity coming towards this, then this is in minus x direction, that is rho s and ds or dn we can say, all are in negative x direction. Since v is the function of only x, these two terms will become equals to 0, then we got dou square v by dou x square equals to 0. Integrating this, we get dou v by dou x equals to a constant a. Further integrating, v equals to ax plus b. Condition 1 applying that x equals to 0, then v equals to 0. Then applying this in equation number 1, we are going to get b equals to 0. Condition number 2, that x equals to x1, then v equals to v1, then v1 equals to a x1 plus 0, which equals to a equals to v1 by x1. Now substituting a and b constant values in the equation number 1, then we are going to get v equals to v1 x1 of x plus 0. This is Laplace equation. So this equation is a Laplace equation and it satisfies the boundary conditions of these two. So this is also known as unique equation. We have E equals to minus dv by dx along ax. Since it is in negative direction, that is minus value decoded, minus v1 by x1 ux. D equals to epsilon naught E, that equals to epsilon naught minus v1 x1 of ux. Now this d is along the negative direction of x, is normal to these plates. This implies d normal equals to minus epsilon naught v1 x1 un, which is nothing but surface charge density rho s. Total surface charge q is given by integral of rho s ds, that equals to integral of minus epsilon naught v1 by x1 un of ds minus epsilon naught v1 by x1 of integral ds, that equals to minus epsilon naught v1 by x1 of s is equals to minus epsilon naught. v1 is v1, but what about the x1? x1 is the distance between these two, that is given by d of s. Capacitance C equals to total charge magnitude divided by the voltage V, that equals to Q divided by the total voltage increased is from 0 to V1. So V1, that equals to minus epsilon naught. Substitute the value of Q is equal to this. So minus epsilon naught V1 divided by D into S divided by 1 by V1. V1 gets cancelled, and we are going to get minus epsilon naught S by D. From the formula, it is only the magnitude, then we are going to get epsilon naught S by D. Capacitance C of the parallel plate capacitor is equals to epsilon naught S by D for air medium. This will become C equals to epsilon S by D, where S is the surface area and D is the distance between the two plates, farads.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.